Welcome to EPG Pathshala. I am Dr. Soumyajit Patro. I am working in Sidhu Kanu Birsa University of Purulia. It is in West Bengal. I am working there as an assistant professor in sociology. Today, I will discuss probability sampling, procedures and principles. You know that in most of the empirical studies, it is quite impossible or impracticable to collect data from all potential respondents, considering the time, cost and labor components that such large scale studies may incur. The time, labor and cost increase proportionately with the increase in the scale of empirical research. Suppose we are interested to know about the average monthly income of adult males and females living in Kolkata municipal area. It is almost impracticable to collect data from all adult males and females living in this municipal area and then analyze and come to a conclusion regarding the annual or monthly average income of the people living in this municipal area. So, what we do? We collect a representative group from what is known as universe or population, and then we analyze the data we collect from that representative group, which is called sampling. Sampling is a process, is a scientific process by which we collect a representative group from the universe. The universe may be very small, the universe may be very large, and the group which we collect as the representative of the population is known as sampling. Now, there are different types of sampling, you know, probability sampling, non-probability sampling. Now, we will discuss in detail about the different types of probability sampling, its advantages, disadvantages and many other things. Aggregate of individuals or units from which a sample is drawn is known as population or universe. In fact, the researchers may like to know about the population characteristics from the findings of the study of the sample. No doubt, the ideal way to have knowledge of the population is to conduct a study on each and every member of the population. Sample is the shortcut way to understand the population characteristics. So, in most of the quantitative research, the researchers draw sample from a large population in order to examine the characteristics existing in the population or universe. The value of a variable calculated from the sample is called statistic, and the value of a variable existing in the population or universe is called parameter. Sampling is the process of selecting a representative group of people or social phenomena to be studied from the population. This representativeness of the sample is very important because it is presumed that the results obtained from the sample can be used to describe the population or universe as such. The individuals selected for a sample are called sample units. A sample consists of sample units when the research is conducted on the entire universe, that is, when information is collected from each and every individual of the population It is called census. Now, we should look at the features of a good sample. These are: sample must represent the universe. It should be unbiased. Sample size must be adequate to produce reliable results. There are different types of sample, and the researcher has to pay sincere attention in selecting the appropriate one. Otherwise, the results of the study will be misleading. Prior knowledge of the various characteristics of the population is essential for selecting the right sampling design. In order to draw a sample, a source list, the complete list of the unit of the population is known as source list or sampling frame, is required. Voters list, for example, can be used as a source list for many social science research, but in most of the cases, the researcher has to prepare the source list. It is although not very easy always. Researchers face difficulties to prepare a source list if the population, for example, is mobile. Sometimes it is also impossible to identify the actual units of the population. If, for example, we want to collect a sample from the student communities who have tendencies to commit crime, it would not be very easy to identify the right persons and to collect a sample from them. Now, why do the researchers prefer sampling? Complete enumeration, or what is called census, requires much time. Sampling selection of a representative part from the whole saves it. Many social science research are time bound, so sampling becomes inevitable to complete the work in time. Secondly, sampling saves labor and money. Thirdly, sample study yields more precise results. Fourthly, from the administrative point of view also, sampling is preferred. Fifthly, concentration on a comparatively small group helps collect accurate data. Sixthly, the magnitude of error can be calculated in most of the cases, particularly in case of probability sampling. Lastly, the degree of accessibility of the units of study is higher in case of sample study than that of the population study, which is often called census. Sampling can be of two types: probability sampling and non-probability sampling. In case of probability sampling, each item of the universe or population has a determinate or fixed chance of being selected. The idea behind probability sampling is that a sample will be representative of the universe from which it is selected if all members of the universe have an equal chance of being selected. This sampling method is sometimes called EPSEM, equal probability of selection method. In short, EPSEM. You know that a good sample should accurately represent the population. Probability sampling enhances the degree of representativeness, and a random method of selection in which each item has an equal probability of being included in the sample is the key to the probability sampling. A major advantage of probability sampling is that sampling error, that is the degree of expected error for a given sample design, can be calculated. Non-probability sampling, on the contrary, does not follow the rule of probability. Now, I shall discuss sampling in quantitative and qualitative research. Sampling techniques vary with the nature of research. In quantitative research, the researcher generally focus on numerical aspect of social life through the collection and analysis of some statistical data like average age of the population, average income, level of education, dropout, etc. and etc. For this purpose, he or she wants to draw a truly representative sample from a large population and tries to understand the population parameter through sample stats. So, probability sampling is the most appropriate for quantitative research because it produces more accurate results expressed in terms of numeric data than the non-probability sampling, and hence sampling error can be calculated. There are different types of probability sampling. First, simple random sampling. This is most popular. When each unit or element in the population or universe has an equal chance of being selected in the sample, it is called simple random sampling, in short SRS. According to P.V. Young, the term random here does not mean haphazard, careless, unplanned, hit and miss. Rather, according to the accepted standard of statistical sampling, every effort should be made to control the choice of items so that every item in the universe shall have the same probability of being included in the sample. Generally, each unit in the population is identified by a number, and then lottery method is used to select the sample units. Sometimes random number tables are also used. Simple random sampling may be of two types: simple random sampling with replacement and simple random sampling without replacement. In case of simple random sampling with replacement, the units selected at each draw is reinserted in the container before the next draw is made. So, the size of the population remains same at each draw. Simple random sampling with replacement is often termed as unrestricted random sampling. Most of the statistical theories are based on simple random sampling with replacement. In case of simple random sampling without replacement, the units selected are not replaced or returned to the original population. So, the size of the population or universe changes at each draw. When the population is homogeneous, simple random sampling can be a very good option. Stratified random sampling is also a type of probability sampling. Simple random sampling does not ensure the inclusion of every segment of the population, as it is based on random, generally lottery method, on which no one has control. To ensure the representativeness of the sample, often the entire population is divided into some strata on the basis of some criteria relevant to the study, and then subsamples are collected from each stratum following random method. This type of sampling is known as stratified random sampling. There are two types of stratified random sampling: proportionate stratified random sampling and disproportionate stratified random sampling. In case of proportionate stratified random sampling, the specified characteristics of the population are reflected in the sample and in the same proportion in which they are distributed in the population. In disproportionate stratified random sampling, the size of the subsamples is not proportional to the respective population strata. Here, generally equal number of units is selected through simple random sampling from each stratum. Another type of sampling is cluster sampling. According to Alan Bryman, cluster sampling is a procedure in which at an initial stage the researcher sample areas, that is clusters, and then samples units from these clusters, usually using a probability sampling method. For example, in order to select a sample of women voters from a town, we can divide the town ward-wise and then select a sample of wards by simple random sampling. The final sample of women voters then may be selected from each selected ward, again by simple random sampling or by stratified random sampling. Cluster sampling is less expensive. There is also multi-stage sampling. In multi-stage sampling, the researcher proceeds through a number of stages, selecting a predetermined size of population from each stage by simple random sampling. For example, if we want to select a sample of urban people of West Bengal, we have to divide the state on the basis of districts. Then we can select a sample of districts by simple random sampling. These selected districts may again be divided into different urban areas. In second stage, we may select a few towns from those by the same random method. These randomly selected towns may again be divided into different wards and a sample of words may be selected by using similar sampling method. The final sample may be selected from the list of the residents of these words. In this multi-stage sampling, a random method is applied at each stage. For a large population, this kind of sampling is very useful. Now, I shall talk about multi-phase sampling. When some general information is collected from all the units of the sample and some specific information from subsamples of the original sample, it is called multi-phase sampling. This sampling technique is also based on random methods and it can be combined or used with other types of sampling techniques. For obvious reasons, multi-phase sampling saves time and money. It is time consuming and unnecessary to ask every question to everyone. Multi-phase sampling also reduces the burden on the informants. Systematic sampling is also an important type of probability sampling. According to Earl Babi, systematic sampling is a kind of probability sampling in which every kth unit or person in the list of the population is selected for the inclusion in the sample. Generally, k is calculated by dividing the population size by the desired sample size. K is called sampling interval. For example, suppose you have decided to conduct a study on the reading habits of the students of a particular class in which there are altogether 100 students. You also have decided to make a sample of 10 students for this. You can use the attendance register of the students as the source list. Every student in that register has a roll number like 1, 2, 3 up to 100. Sampling interval k here is 10. 100 divided by 10 is equal to 10. So, sampling interval is 10. To start with, you have to prepare 10 discs numbering 1 to 10 and then select the first number by lottery. Say the first number comes 6 through the lottery. Roll number 6 is then included in the sample. The other sample units would be the students having roll number 16, 26, 36, 46, 56, 66, 76, 86 and 96. Remember, the sampling interval is 10. So, the final sample would consist of roll number 6, roll number 16, 26, 36, 46, 56, 66, 76, 86 and roll number 96. The first unit is selected at random. Then every kth unit is selected from the list of the population. In order to select a systematic sampling, a complete list of population with proper numbering of the units is very essential. But any purposeful arrangement or rearrangement of the units in the list may produce biased sample. Then area sample. Area sampling is a type of sampling in which small areas are designated as primary sampling units, in short PSU, and the households interviewed include all or a specified fraction of those in these areas. Area sampling is similar to multi-stage sampling. The only difference is that here the total area under study is divided into smaller areas and then a sample is selected following random method. After the selection of areas, all the households may be studied like cluster sampling, or further subsamples may be selected, again classifying those areas. In agricultural and market surveys, this type of sampling design is used. Now, the most frequently asked question is, what would be the size of the sample? If it is a probability sampling, the researchers can determine it with the help of a statistical method, but this statistical procedure is not easy and it requires prior knowledge of the population, which often the researchers do not have. Lawrence Newman has informed us about a convention that can help the researchers in deciding the sample size. It should be noted that large sample size does not always ensure the representativeness of the sample if the population is heterogeneous and the sample is poorly crafted. In case of qualitative research, even a very small sample can produce accurate and fascinating information, but this cannot be said of quantitative research. On the basis of the principle, smaller the population, bigger the sampling ratio, Newman suggests the following. Note, sampling ratio is the ratio of sample size and population size. For a small population, about 1000, sample size would be 300, that is 30%. For a moderately large population, about 10,000 population, sample size would be 1000, that is 10%. For a large population, about 1,50,000 population, sample size would be 1500, that means 1500, that is 1% of the population. For a very large population, about 10 million population, sample size would be 2500, 2500, that is only 0.025%. Now, sampling error. According to Bryman, sampling error is the error in the findings deriving from research due to difference between a sample and population from which it is selected. This may occur even when probability sampling is employed. This error creeps in the result of your research because of the fact that you have conducted the study on the sample instead of the population. In census, sampling error is 0. In case of probability sampling, the more the sample is a representative one, the less is the sampling error. Probability sampling ensures the chance for each unit of the population to be included in the sample. There is no scope, there is no place for the choice of the researchers. So, personal preferences, personal choices do not creep in and the sample remains unbiased. In this way, some sort of objectivity can be ensured. One of the advantages of probability sampling is that in probability sampling, the researcher can calculate the sampling error, how much error has been introduced in course of this process. This is called sampling error. However, with the growing popularity of the qualitative researches, the use of probability sampling is on the decline.